Good morning. Today's Friday, February 14th. Happy Valentine's Day. I'm going to do our notes in pink and red. Okay, so in your packets, you want to turn to page 10. We're going to fill out 10, 11, and 12. So today we're going to look at rational versus irrational numbers. Rational numbers are numbers that can be written as fractions or decimals. Rational numbers include repeating and terminating decimals. And you might wonder what terminating means. Terminating decimals are decimals that end or stop. The square roots of perfect squares are rational. Okay, then irrational numbers cannot be written in fraction form. Irrational numbers include non-repeating and non-terminating decimals. And irrational numbers are also the square roots of non-perfect squares. So in this space over here, an example of an irrational number would be pi, because this is approximately 3.14159265535. I'm going to put the ... So see how this decimal does not repeat and it does not terminate. So that would be an example of an irrational number. Okay, we're going to fill out if it's rational or irrational, and then why. I'm going to try to do red for rational and pink for irrational. So -12, that is a number that terminates. So this one is going to be rational. I'm going to put an R for rational. And this is because the number terminates or ends. Oh, pi, I kind of gave that one away. Pi is irrational. I'm going to put an I because it's a non-repeating, non-terminating decimal. Oh, I should have written smaller. Okay, next is 0.6. So look here. This decimal terminates, it ends. So that's going to be rational. So the decimal terminates. Okay, 7/8. Remember 7/8, it says rational numbers can be written as a fraction. Irrational numbers cannot be written as a fraction. So because this is a fraction, that's going to be rational. So I'm going to write fraction. Okay, look at this number, 0.123456. I don't see a pattern, and I see these ... dots, which means it's going to keep going. So this one does not repeat, does not terminate, so this one's irrational. So I'm going to put non-repeating, non-terminating decimal. Okay, this one, what does that bar mean? It means it's going to keep repeating 33333. So look for up here, which one says it can repeat? This one, rational. Oops, sorry. So rational, repeating decimal. Okay, this one, square root of 20. If you need your list, do you see 20, on here? Nope. So this one is not a perfect square. So non-perfect squares are irrational. So I'm going to write non-perfect square. Okay, this next one, -1.75. That decimal ends. Which one shows that a decimal stops? This one, rational. So decimal terminates. And then this one, yes, there's a negative, but can you do the square root of 121? So look at your list. Is 121 on here? Yep, it's 11. So this one's a perfect square. If it's a perfect square, it's a rational number. So our reason is perfect square. If you need to pause the video to catch up, do that. But make sure you have everything filled out. I'm going to flip to the next page, page 11. So we're going to practice identifying rational and irrational numbers with the questions below. Joseph wants to find the side length of a square that has an area of 150. Should his answer be rational or irrational? Why? So we've done a lot of these where you have a square, an area. You should first draw a picture. Areas if you multiply the sides, so I'll call them x and x. Remember, square has the same side, so I'm going to use the same variable, x and x. Area is the inside, 150. Remember we talked about you have to write an equation and draw a picture for these problems. So here's my picture. To find area, you do x times x, which is x squared, equals 150. How do you find a side? How do you undo the square? You're going to square root it. So it's just asking if it's rational or irrational, not actually what the square root of 150 is. So looking here, is 150 on here? Nope, because it'd be somewhere between here. So that means because it's a non-perfect square, this one is going to be, what color did I do? Non-perfect square is irrational. So I'm going to do that in pink. So irrational, because square root of 150 is a non-perfect square. Okay, I'm sliding to number 2. Which value or values from the following list of numbers is not a rational number? So we're looking for the irrational. So rational, if you need to flip back, the decimals, they can be fractions, they can be decimals that repeat or terminate, and they are perfect squares. So this one, 8.224, that one stops, it terminates, so that one's rational. 5/9 is a fraction. Remember, fractions are rational. Square root of 25, that's a perfect square, so that one's rational. This bar means it's a repeating decimal. Repeating is rational. Square root 30, is that a perfect square? 30 is not on our list. This one's irrational. So I'm going to circle that one. Square root 30 is irrational because it is a non-perfect square. Okay, I'm scooting down to number 3. Brad converted 5/11ths to a decimal, and his result was a repeating decimal. Does this mean that the value is rational or irrational? So first of all, I notice it's a fraction, and then it says repeating decimal. So if you need your list, fraction, repeating decimal. So that means this is a rational number. So 5/11ths is rational because it's a fraction and repeating decimal. Okay, moving to 4. We're going to write down if they're rational or irrational. First number, I notice there's no dots, so it's not continuing, and it just stops, which means it terminates. So that one's going to be rational. This one, there's dots, and there's no pattern. See, 4, 5, 6, 7. So there's no pattern, meaning it's not repeating, and the dots means it's not going to stop. So that one is irrational. This one, 3.456, then that bar means the 7's going to keep repeating. Repeating means it is rational. Okay, scooting to 5. So 6 plus the square root of 30. Is the square root of 30 a perfect square? Nope, it's not on our list. So you're adding a 6 plus an irrational number, so that means it's still going to be irrational. 6 plus 30 inside the square root. 6 plus 30 is square root of 36. That one, 36, is a perfect square, so that is rational. Okay, this one's different than B. So square root of 6 and square root of 30, those are separate. You can't combine it like this. Square root of 6 is a non-perfect square. It's not on our list. Square root of 30 is a non-perfect square. It's not on our list. So it's an irrational number plus an irrational number. It's going to stay irrational. Okay, I'm scooting over to 6. Give it an example of an irrational number that's greater than 10. Ooh, you know what? I'm going to use my chart. So if 10 squared is 100, greater than 10 would be the square root of anything between 100 and 121. So maybe I'll do square root of 115. That's not a perfect square. The answer is going to be greater than 10. Okay, I'm going to flip to page 12, last page. Got this table up here. I'm going to do the first 2 up here with you, and then you are going to complete 3, 4, 5, and then the rest of the ones at the bottom. So 5 and 1/25, that is a fraction. Remember, fractions are rational. So our explanation is going to be, it's a fraction. Square root of 126, is that a perfect square? Is this on our list? Nope, it goes 121, 144. So that's a non-perfect square, which means it's going to be irrational. Okay, I'm going to check, we don't have school Monday, so I'm checking on Tuesday that you have the rest of this done. There's no answer checker for it. But you are going to, actually, you know what? I am going to make an answer checker. There's going to be an answer checker for the remaining questions, 3 through 10. Make sure you do it in class. Have a good weekend.